Hello and welcome to yet another episode of our knowledge sharing series. It is good to see you. It is good to have you for yet another session of demystifying the sector through conversations. Yes, I can see guys are streaming in. Just a reminder, we are live on LinkedIn, we are live on X, and we're also live on YouTube. Remember to also follow us for more conversations that we bring you every month. Karibuni sana, karibuni sana. Yes, today we are tackling an interesting topic. It's also good to note that it's a topic we've partnered with AHK. Hannah will be telling us more about AHK. But it's good to see, yes, karibuni sana, I see you, karibuni sana. So today we'll be talking about something that we'll be trying to avert a crisis or something that could be a crisis in the future. And there's no better way to plan to avoid future crises than to plan now. Planning now is a good way to avert them in the future. We'll be tackling PV recycling, a concept that is being adopted here in Kenya. And with us today are experts. I will not introduce them. Hannah will introduce them or allow them to introduce themselves. But we are happy to have Peter, Sean, and Romano with us to try and delve into this topic, very timely topic. We are seeing a lot of adoption of solar, renewable energy in Kenya, solar in particular, more so in the C&I space. It's good to note that solar in Kenya is largely installed in the captive sector. The captive installations for solar surpasses the grid installed capacity that we have in the country. And so with over 300 megawatt of the 600 C&I installed in Kenya, that's quite a huge capacity, and it warrants this conversation. What happens to all these solar panels when they come when their lifespan comes to an end? How do we deal with them? How do we deal with them sustainably? And so to lead us in that conversation, we have Hannah. I will hand over the stage to her now to take it away. Karibu sana, Hannah.
Thank you so much, Penina. Happy to be here. Thank you to the whole Esak team for hosting us today on this topic. And dedicating really the platform to this topic. My name is Hannah, and I work for AHK. That's the German Chamber of Commerce for Eastern Africa. I'm based here in Nairobi. I've been working for AHK now for 3 years, and I'm heading our Competence Center for Energy, Environment, and Sustainable Economy. So what AHK usually does is we connect private sector. So we connect the German private sector and the East African private sector. We have a mandate for the region. So I'm mostly active in Kenya, of course, where I'm based. We have a small office in Dar es Salaam, and we are also active in Uganda, Rwanda, and Ethiopia, as the majority countries. And our session for this evening is the topic of PV panel recycling, which is, of course, a very interesting topic, as I find all topics that kind of are in the nexus of, let's say, nexus energy water. Nexus in this case is energy waste. So specifically, solar industry meets waste management, and that on a hopefully localized basis. And this is why we have asked Esak if there would be a potential to do some form of session together to kick this conversation off a little bit. We acknowledge, of course, that this might be more a start of a conversation and maybe more around an awareness session of this. So I really hope that after the session, the conversation on this continues. And yeah, we want to know and explore for today, what is the status of PV panel recycling in Kenya? Maybe also taking first a bit of a global look on the situation and on the industry, then hearing a bit more from industry experts. How is it on the ground in Kenya? Maybe venturing slightly into East Africa, let's see. And what are the challenges as well? And what are the points to consider for solar companies where, yeah, what to have in mind. So I would love for the experts to introduce themselves. I would just, let's do it in the order of talking anyhow. So Peter first, then Romano, then Sean. Yeah, please go ahead.
Yeah, thanks, Hannah, and thanks to the Esak team for having us. So my name is 𝗞𝗲 𝗣𝗩. I work for 𝗣𝗩 Solutions, which is a PV manufacturer, and yeah, we will hear more from me soon.
Romano, do you want to take the mic?
You're on mute, Romano. Or not?
It may be your headphones. No. No. Okay. Maybe Sean, take over for a moment, and then we'll let Romano have a minute.
So my name is Sean Mumford. I am the Managing Director of 𝗣𝗩 in Kenya. We're an e-waste processing facility, and we work very closely with the solar industry, historically more with the small home solar players, but where they've had more waste coming out in the last few years due to the quality of those products compared to some of the more sophisticated ones coming out the bigger environment. But yeah, that's it.
Great. Do we have Romano back already? No. Okay, so we'll give him a moment to fix the audio, and in that we will just jump right into Peter for the first presentation. We were very ambitious, so each of you have 7 minutes to present quite some complex contexts, but yeah, we wanted to leave as much time as possible for a Q&A later. So yeah, write your questions into the comments function, into the chat function, and then we'll pick them up after the 3 presentations later. Over to you, Peter.
Thanks, Hannah. Thanks so much. I hope you can see my slide. Maybe a quick sum up. Wonderful. Yeah, so again, I'm 𝗞𝗲 from 𝗣𝗩 Solutions, an energy and circularity expert. As Hannah said, we don't have much time, so I really want to just highlight a brief aspects of my presentation. And I'm very happy to also get connected later on for more follow-ups and also within the session, in the Q&A session. So 𝗣𝗩 Solutions, who is it and why am I here? 𝗣𝗩 Solutions is a PV manufacturer founded in 2012, headquartered in Germany, but the main manufacturing is happening in China. We have over 500 employees, and last year we reached the landmark of like 20 million modules delivered for mainly the off-grid sector, like which Sean just mentioned, which is like smaller panels, less standardized panels ranging from like 1 watt up to 200 watts. So this is our core business. We're supplying customers in Kenya. Like you will not find our name there because it's an OEM supplier relationship, but like customers in Kenya like BioLight or Sun King are our panels which we are manufacturing. And this year, our founders, after like producing these millions of PV modules, have set a step forward and founded 𝗣𝗩 East Africa in Kigali with my support. And here we want to specialize more now on closing a loop, not just manufacturing panels, also like what happens afterwards with our PV panels. So that's why we're looking into testing, repair, and recycling solutions. And yeah, quick words to myself again. I've been living in East Africa for the last 13 years. worked in different research institutions, but also solar energy companies directly, as well as e-mobility, and very passionate about anything which is coming to energy and circularity. So why PV recycling now? As Hannah said also in the beginning, let's take a bit of a global perspective on the issue. On one side, we're seeing globally photovoltaic still scaling hugely and accelerating all over the place. So just last year in 24, 600 gigawatt, just to show in some big numbers here, 600 gigawatt of new solar was added. And right now this comes to like a 2.2 terawatt installed capacity. On the other side, while the installation is accelerating, also decommissioning of the first wave has started, and the first raised wave is approaching, mainly in those countries who have been in the first wave of installations, like in the Northern Hemisphere. And there's a lot of studies ongoing, and it's projected that by 2050, so in about 25 years, we will have a cumulative waste of 60 to 78 million tons of PV waste, because they will reach the end of life, they will need to be dealt with. So there's a big problem coming, but therefore also a big opportunity. And we see in many countries already a momentum in terms of the circularity movement and policies. Many of the European countries have adopted to the EU standard, which is the EPR and 𝗣𝗎 requirements. Same happening in Kenya right now. It's, from my personal perspective, it's still much on the early stages, and there may be some first hurdles to overcome as the policies are getting implemented. But Kenya and East Africa in general, like, it's moving in the same direction what like other countries have done already. And so it's really signaling that the global market is heading towards the circularity approaches. And yeah, so why does this matter? So like, we cannot just install PV all around the world without thinking what happens after. And that's why I said like Opus Solutions also looking into that as a primarily manufacturer, but also now looking into what can we do as an expert. And while the topic is maybe named recycling today, I do believe there's also a big need for repair and reuse before we recycle. And I will speak to this in a little bit. So yeah, on this slide, a quick overview on how we from Opus see like what should happen in each country. And I believe in different countries, these aspects are implemented in different stages. So classically, like if a PV panel is decommissioned either from a small solar home system or from bigger installations like mini grids, they should go through a certain assessment and triage stage, then attempted to be repaired and reused where possible before recycling. So I just want to also speak a little bit on a high level what can be done here technology-wise, because that's where Opus Solutions is trying to bring in technology solutions into East Africa in general. So really on the assessment side, before we say, look, it goes to recycling, a basic visual check should be done. Electrical, like testing, what is the output of the panels, and optional, but we're bringing this in right now as a solution to Rwanda and to Kenya as like EL, like electroluminescence imaging, which shows then how our micro cracks develops or hotspots or certain issues in the PV panel which cannot be seen by the naked eye. And once the panel is assessed, it can be then triaged to, can it be repaired, or does it have to go straight to recycling? And that's where on the repair side, from an assessment we've been conducting right now, a lot of companies are not yet equipped to attempt a repair. So for example, frames or cables or junction boxes are repairable if the right spare parts are available, but we know that spare parts availability can be an issue, especially if panels are maybe not standardized. Broken glass, usually not repairable, goes straight to recycling. And where we as Opus Solution with our manufacturing expertise want to come on is, for example, on the broken solder joints, which are behind the glass and the back sheets. So there are technologies like EMI spot welding, which are prototypes right now, but we're trying to establish this as a process in East Africa so that like loose solder joints could be repaired. And again, all to target to reduce in the first place the recycling rate, creating more value on a proper second market. But eventually then, if things cannot be repaired, they go to recycling. And yeah, so speaking about recycling today on a global perspective, what has been proven as a concept all around the world is like mechanical dismantling to recover aluminium from the frames and copper from the cables and the junction boxes, and then removing maybe the glass depending on the grades. So there's multiple countries and companies who have established recycling facilities, mainly in Europe and in Northern America, because they have like very high volumes of PV installed, and they had to think about these solutions much earlier on. What becomes more interesting in the future and where companies are innovating right now is like on higher value recovery. Maybe those who are following the market of gold or silver, so like those prices have been increasingly going up recently on the war market, and therefore there is silver and other high value materials in the panels, and companies are looking more into how can we get and extract more of these high value materials from the PV panels. Because in the first wave of recycling methodology, this was not considered. It was more on the mechanical side. Yeah, if anyone is interested in specific processes or companies, I'm happy to share some links to those companies. And yeah, and as I was not giving too much time, coming to an end of this part of the presentation, we from Open Solutions believe like there's a near-term model for Kenya or East Africa where it's first repair and repurpose and then recycle. There's still value in many of those panels, so let's not waste that potential of resale value. But recycling becomes more economic, and I think and Rousseau and Sean will speak more about this. But there's still certain barriers. And I think countries like Kenya and Rwanda, who have like very strong policies in place and a good business environment, can really play a regional role here. And where we as East Africa Open Solution want to help is bringing our know-how from like the last almost 15 years, bring in technology for testing and repair, but also for recycling, because we have a good network in Germany and in China to build those bridges to the Kenyan or East African market, to those global markets. And yeah, and right now we're working as the local company was just founded this year. We're working on a market and technology assessment, and that's where like we're asking us to collaborate with the not just the presenters here, but also those who have connected live today. Whoever wants to contribute to this market study and is interested in collaborating or hearing more, I'm very happy to get in touch. And yeah, hope to hear more later in the coming sessions. Back to Hannah.
Thank you, Peter. Yeah, and I think it's very important that you touch on basically the circularity principle, because of course, before you talk about recycling, you also need to talk about reuse and repair. So that is something that we wanted to highlight here, because those are definitely priorities, yeah, when it comes to dealing with second life and also end of life. So before we hear from Sean from the recycling perspective, we want to hear from Romano from the C&I perspective. And I hope that your audio is working now. Let's test it out. No, still not. Maybe it's your headphones. I don't know if there's an output issue. Yeah, Penina, maybe you can do some troubleshooting in the background. Okay, remove the headphones from your laptop if possible first, Romano, if you still have. And then you want to try and join again? There could be an output issue. Okay, let's test this out first. Then I'll use the time to check up on the comments, and I see there's still not so much happening there. I mean, yes, of course, there's only one presentation that we've heard so far, but please feel free to already put some comments or questions in the chat function. And yeah, I think that is one. Then maybe, Peter, I seize the time for a follow-up question already to you. Did you mention the horizon for your study at all? Until when do you need input?
Yeah. So we started in May. That's when we kicked off our activities, and towards the end of the year, we want to collect input from stakeholders in Kenya and Rwanda, because that's where we're focusing on. So yeah, in terms of input, would be great within next 2 months, and then we're aiming to have a white paper to inform the sector, published by either end of the year or early next year. And as a company, we're then also, based on all these input and challenges and observations, we will decide where will it be viable for us to start collaborating and working on this more broader PV repair and recycling issue.
Got it. Okay, that's really interesting. All right, given that Romano's not yet back, and I know there's some troubleshooting happening in the background, I would say we go a bit, yeah, we change up the program a bit, and then I would just say, Sean, you take the next presentation, and then we'll let Romano take the spot after your presentation.
Great. Can you see the slides?
Not yet.
Okay. Now? Yeah?
Yes, that's
okay.
it.
All right. So a little bit about 𝗣𝗎 in Kenya. We established ourselves in Kenya in 2017. So we've been around about 8 years now. We are very small. Obviously, the e-waste sector has been quite small in Kenya, in the formal sector, because the informal sector does most of the work. And our focus is on trying to deal with the difficult fractions. So we don't try and replicate the easy stuff, because there's plenty of people doing that. So we're looking at how do we deal with the difficult things. So that is why PV recycling has come up. Our biggest customer base has been the off-grid solar companies. And we have been historically just receiving everything that they do. And one of the big problems is solar panels. It's only in the last 2 years that the discussion really has been around what to do with them. So if we look at the sort of background as we've got here, Peter's mentioned it, the numbers are increasing. And in Kenya, there's no opportunity for disposal of them safely. So historically, we have shipped them to Dubai. We have an associated company in Dubai, also called 𝗣𝗎, but we're independent of them. And they've been landfilling them in Kenya. So we typically are doing around 2 tons of solar panels a month, so it's quite small. But even that, as it scales, it's not viable to ship that to another country. And so that's not going to be a long-term solution. And so we've been looking at how we solve that problem. And it's only in the last 2 years that really there's been reasonable discussions about options for that. So currently what we do, we receive the panels. As Peter said, we remove the cable, and we have equipment to strip and granulate and extract the copper from those. It's not easy on the small home solar system. You know, it's low quality 12-volt cable. You can't really do that manually. So what happens in the informal sector is that's burnt. We want to avoid that. So we have equipment to deal with that. And then we've been shipping the panels for disposal in Dubai. One of the pushes for us is that Dubai have stopped landfilling, which is great. And the reason for that is that they have decommissioned one major plant, which is 350,000 solar panels, which is 9,500 tons. So if you actually get pictures now of their warehouse, basically the desert outside is just solar panels piled up. So they're putting in plant to deal with that kind of volume. which is great news for us because it means we can piggyback off that. So what is our objective as a first step? We want to set up the first solar panel recycling unit, and AHK have luckily agreed to fund this because while we believe that it will be commercially viable while running, certainly to do it as the first pilot, the capital expenditure is not viable. So having this funded externally really will help us. We have 24 tons of solar panel in stock, and that's what we will process first. And what we plan to do is basically just remove the glass that we can then recycle in Kenya, but that reduces by 80% the mass of the panel. The rest we will send to Dubai. Again, if you look at what they're doing, their investment to deal with 9,500 tons means that they can put in that second phase that Peter was talking about, which will grind up the back of the solar panel, extract the copper, extract the silica, the aluminium and the silver where that exists, and so on. So that's what they're putting in. So for us, the first step is reduce the problem by 80%, use that glass in Kenya, and there's opportunities to do that, and then ship the rest out to Dubai, which gives us that first phase. Once we prove that that is viable, the idea is hopefully we can offer a better option to our partners and customers and the wider community. Instead of saying we're taking panels and chucking them in a landfill in a foreign country, we now have a solution which talks about actually the circular economy properly. So that's been part of our problem. We haven't really had a great story to tell, but we do now. If we can get the volumes up, then the idea is to then replicate the glass removal in counties and other larger parts of the country. So there's no point in shipping again that 100% back to Nairobi. We can do that in Mombasa, we can do it in Kisumu, and potentially we can do that in other countries as well. And then if the volumes are high enough, we can stop shipping the rest of the panel back to Dubai, and we can put in the second phase in Kenya. But it is, again, like Peter, we are cautious. We have seen too many people try and do too much too soon and just go out of business, and that makes no sense. So we have a very structured approach to how we think things will work and how we can work with other partners. So we don't necessarily think we're always going to be removing the glass in all the places. We will find partners who can implement that, and we do the second phase. So the impact is basically to avoid the dumping, provide an alternative to people in Kenya so that they're not, they have an opportunity. It's all very well telling people not to do things, but unless you can tell them what the alternative is, and unless you can get that to a level that's economically possible, it doesn't make any sense. And one of the points, again, which Peter alluded to, is the EPR framework, the PROs being set up in Kenya, money now, in theory, being put aside for dealing with end of life. So our project will also identify what the costs are involved and what's needed to be provided by the greater community in order to deal with this problem. So that's quite an important one, is being able to say it's never going to be a profitable business recycling solar panels. So some money has to be injected from somewhere, but until you can define what that amount of money is, you cannot work out where it's going to come from or how much. So the long-term significance of the project is scalable and replicable model for Africa. So we believe that if we do something in Kenya, a lot of that is useful elsewhere. We cannot look at models from other countries in the global north. That doesn't really make sense. But if we can make it work here, that's what we want to do. And then we're more than happy to work with other people who want to do it in other countries. They can come, get training, look at how we're doing things, and so on. But it is all about taking what is, we are a leader in this area, but we have to be a leader in terms of rolling out solar. We have to be a leader in cleaning up after ourselves as well, and that's quite important. That's it.
Thank you, Sean. All right, and now we have Romano back in the call. How does it look for the audio? No. No, I'm sorry, Romano. Yeah. Okay, so maybe keep trying, Romano. Yeah, I'll have a few questions already rounded up for Peter and for Sean. You'll just yeah, can you just try again? Maybe a bit no, not on my side. I also, Sean, I see you nodding. Okay. All right. Try it a bit further, Pernilla. If you could just maybe run another background check on that, and then maybe I wanted to do this after Romano's presentation, but then let me step in here to just clarify or maybe explain a bit which project Sean was mentioning for the 𝗣𝗩 recycling machine. So the reason that we are, as AHK, active in the e-waste sector currently is because of a project run by our Ministry of Environment. And that is a project running from 2024 until around Q2 2026. We've had quite a lot of activities within the project already, basically 4 main pillars, including a study, a summit that we've done, and PRO engagement. And then the last bit is a pilot project. And this is a project that, with a lot of applications coming our way, then in the end, EnviroServe Kenya won the bid. For 𝗣𝗩 recycling, we had a bit of other things as well, including battery testing, for example. That, of course, is all also highly interesting. Yeah, but it was 𝗣𝗩 recycling in the end, based on the innovative approach of trying to recycle locally and also find outlets and business channels for the used glass. So that maybe is one background. And then the other background, since now both Sean and me, we've used the word PRO, I wanted to say that maybe this is not something that maybe everyone in the call knows what we're talking about. When we say PRO, we mean producer responsibility organizations. So these are organizations formed on a national level that take care of certain waste streams. And this is following the Sustainable Waste Management Act in Kenya of 2022, and the then finally extended producer responsibility regulations gazetted in 2024 that require producers and importers of e-waste and all different other kinds of waste. So there's also packaging, for example, there's also textile waste, also hazardous waste, to take care of all the products that they put on the market for their end of life. And companies and producers, importers have the chance to join such a PRO and pay membership fees, and those would then be rechanneled into financing the end of life management of the items put on the market. So this is also an opportunity for Kenya, because a lot of the items, especially also 𝗣𝗩 recycling, it's actually a negative business case. So the money to take care of them has to come from somewhere. Of course, this is very different to, for example, let's say copper, to where there's a clear business case to be made. So we are talking about other forms of e-waste that at the end of life rather cause money instead of making value. And this is important as well for all different kinds of solar companies. I mean, Peter and Sean spoke a lot about off-grid solar. That was kind of the initial movement of the EPR system in Kenya. Off-grid solar companies through, for example, 𝗣𝗲𝗄 coming together to kind of want to tackle, at least see how can we deal with end of life. But we also know that this is, of course, a topic in the C&I sector, albeit maybe yet smaller. So this is why we are having the session here with Esak now. Yes, and basically what we also wanted to hear a bit from Romano is how is it with decommissioning and setting funds aside in order to take care of end-of-life management. So I hope that he can join a bit further in to kind of take care of this. But what I wanted to then first kind of see is in the comments section, I see Andrew asking Sean, in your experience, which materials, so glass, silicon, silver, aluminium, copper, plastics, etc., are mainly recovered, and at what efficiency rates? Can you say something towards that?
Sure. So in terms of our experience, of course, we have not been doing the panel side of it. So if we look at the aluminium from the frames, that's easy, that's 100%, and that just goes to smelters in Kenya. If we look at the copper that's coming out of the cable, we're recovering the PVC from that. The outside cable, that's 100%, that's easy. Then the inner cable, we put through shredding, granulating, and so on. And that we're recovering probably about 95%. Yes, Romano, we can.
Good.
Right. Let me finish just this question, and then you can carry on, I think. So the PVC is you know, it comes out of the cable. That's typically got a little bit of copper in, but again, we are able to provide that to people who make shoe soles, for example, for that. And the copper itself, which is pretty pure, goes straight to the smelter. So from the cable, that's not a problem at all. From the aluminium surround, that's not a problem. The next phase, which is about the glass, again, Peter mentioned sort of downcycling that. The problem with it is it's tempered glass, so you can't really recycle that. And also Kenya, unfortunately, doesn't really have a strong glass recycling facility anyway. I think partly because of our energy costs. But we know that that can be ground up. It can be used for things like sandblasting. It can be used for things like media filters in swimming pools and other water systems. And we also think that it can be added to plastic bricks, for example. It certainly can be added to cement, but that's a different story. So we think that there's a good opportunity to reuse that, again, in a very Kenyan kind of approach, where we've got people picking up waste plastic and making bricks and things like that, instead of putting sand into that. In terms of the other stuff that comes out of the second phase, again, you know, the cadmium, the lead, that's a very important point. And that's the reason why we landfill in Dubai, or have been landfilling in Dubai. So for now, that would go to that equipment. The lead hopefully will be extracted. The cadmium, I honestly can't answer as to how that would come out, but there will be multiple processes involved. You grind everything up, you then sort things through different processes, and it'd be very important for that stuff to come out. Now, some of that, you know, things typically get burnt up in heat or mixed in with stuff and then go back into the process. So I don't know the exact phase of that. I haven't been looking too much in the detail of that second level. But extracting the aluminium, the lead, the silicon as well, those are all pretty high rate, I think, if you get the right equipment. But you do need the volumes, and you know, that's the problem. But Dubai have that. That first 350,000 panels, there's another 750,000 waiting that haven't even come to them yet. So, you know, you can see these are large solar farms, nothing like what we're doing. We have a few of those in Kenya, but not to that level. But the idea is piggyback off on that technology, and once that's proved and then can scale down to something for Kenya, then we put that in Kenya as a second level. But it also means we've got to get our volumes up high enough to make that viable.
All right. Thanks, Sean, for taking that first question in between. So now over to Romano for your presentation and perspective. What would be a webinar without some technical difficulties, right? I think we've lost him from the call, have we?
Maybe it would be good if there's any other questions for people to start putting them in.
Yeah, I think we'll do it like that. Maybe let me ask you this way, Sean. What is your current kind of collection scheme, and in terms of your cooperation with different kinds of solar companies already on the ground? How are you projecting that this could work in the future? And I mean, you have, you know, respective people in the call now. What would you like to tell them?
Sure. So historically, our collection had been mainly from the small home solar market. And the reason for that is they have a lot of value investors that are very keen to see that they have an end-of-life strategy. So if you look at people like Delight and Copa historically, and all the others that Peter has mentioned, they are very good at the whole circularity. So they bring everything back that they get from clients that are broken. They test them, they repurpose them, they repair. Obviously, they're not nobody's actually repairing the panels to the point that Peter has mentioned. That was tried a little bit here in terms of testing, and the volumes weren't high enough to make that work. But again, times change. But everything else is done. And if they do test the panels, if they're good enough, they go out. But if they're not, they can't repair them. And then they come to us. So it has been those kind of people. And the reason is that we charge them for destruction. And that's because we have to remove the stuff and ship it to Dubai. And there's big costs involved in that. This project hopefully will reduce some of those costs. But also, when we're talking to a solar provider saying we're going to landfill them in another country, as I said earlier, doesn't really resonate so much. So I think a lot of things are sitting on roofs and have not been removed. But we also know of a large provider who had 25 tons of panels and basically didn't have the budget to deal with them. So there is a lot of that. People have not been planning for end of life. So it is almost, e-waste in Kenya through the formal sector has really been where people are being, shall we say, coerced into doing the right thing by their investors or by their policies. So some international organizations have policies. Most people have not been thinking about that. We're talking to somebody at the moment. There's a huge amount of batteries, and again, nobody's been budgeting for what they need to do with them at end of life. So we need to be thinking as organizations about our long-term strategy in terms of the full life cycle of everything we're dealing with. And it's been too easy just to throw the stuff in the bin, basically. So that is what's been happening in the past. So we're hoping that with a better answer and with something to show, and hopefully money coming in from other sources, potentially, as we said, the whole Producer Responsibility Act, but even in the short term, to reduce the costs of what we're shipping to Dubai means we can hopefully reduce the cost to the people who need to get rid of things now. So that's the next phase, and we're hoping that all the commercial organizations will start to plan that. We know those panels have typically had longer life than some of the small home ones, and so it's likely that they haven't been dying in quite as big numbers as what we've seen. But I also think that a lot of them have just gone obsolete on roofs and not been removed even.
Yeah. And this is also where I would say, Peter, your research comes in very practically, because we all, when all throughout the project really, but again, when we were preparing this call, we really asked ourselves the question, well, what is the rate right now of maybe dysfunctional end-of-life panels in the country? How many of those would have still a second life in them, but nobody really is testing for it? Where do the decommissioned panels land? I think, Sean, you have the theory that it just sits on land or in some shack somewhere, and it's just not been taken out. Yeah, so there's also a huge number of a huge amount of uncertainty as to what is exactly the current status. I think that's it. Maybe, Peter, just to ask you, would you be willing to give us a preliminary quota, kind of how many panels do you think would still have a second life in them, and they would be definitely coming out positive when you do your testing?
Yeah, of course, giving a rate is a bit difficult to answer, depending on how they've been handled on the transport side, on the installation side. I visited some of the solar home system companies or from the off-grid sector, and one company had a very good decommissioning process, so all the cables were intact, everything looked good. The other company on the other side had a very poor decommissioning system in place, or where the technicians cut the cable, we're not handling them well for the transport. So for the poor decommissioning process, the rate of recovering a working panel is probably below the 90%, whereas for the other one, it's the other way around. If someone really takes care of how I'm removing the panel from the rooftop and how I'm transporting it, being aware that micro cracks can happen if there's not a good packaging, makes a huge difference. But it's hard to give now a Kenya or Rwanda country overview, of course. But I do agree to what Sean mentioned earlier. I think that there's a lot of panels sitting somewhere. People are either not clear, are they working, are they not working, can they be repaired? Due to A, unawareness, and B, maybe the fear of costs involved. And as Sean said, like EnviroServe is trying to bring those costs down so that there can also be higher volumes coming in. And that's where Opus is trying to collaborate and in between and then support on having the right technology also available for assessing then what can be recycled immediately or what can be repaired to give it a second life. And yeah, maybe just a follow-up comment to Andrew, who asked about like the rates of recycling efficiency. So like my understanding from when I did my research is like every company in the northern hemisphere has developed a little bit their own processes. Yes, all very similar, but specializing on different materials. There's a very good market study I can share with you if you reach out, where they analyzed per company what are they recycling, and then like what's the process looking like, and therefore how the different efficiency rates look like. And the last comment maybe to make on an earlier conversation, but we also hope for Romano to join us. I also agree with Sean that the decentralization of like this entire loop and processes will be part of the future solutions. For example, as Sean said, okay, let's then also do glass removal if we have a simple machine in Mombasa, and then only ship parts of it to Nairobi for accumulating the waste. Here, an anecdote, I had recently a call with a German PV recycling company who's now getting stripped panels, so like glass removed, from Australia, and it makes sense to ship a full container from Australia to Germany for then silver removal, because like their process is very specialized in Germany, unlike the part of removal of the high value materials. But yeah, through like removing the glass in Australia, they could pack so many panels in a container that there is like a huge factor in between of like the shipping costs, like he literally said, like are irrelevant. It doesn't matter. Like we're shipping probably $50,000 to $100,000 worth of silver in one container. So like then the shipping costs are not so high in comparison. And that's where like these more advanced recycling processes are moving into, but some of them they're still on early stages and pilot stages, not yet replicated in many locations. So like the companies are still optimizing it before then these machines and technology is also becoming more affordable to have than similar machines, maybe on smaller scale for smaller volumes as well, shipped to like countries like Kenya. And I think that's where the market generally is moving, knowing that it's a global issue. So let's not focus on big machines and big volumes centralized. Can we develop machines which can be more decentralized used? And I think that's where a lot of recycling technology providers are moving into right now.
Can I make a small comment as well? Is that while I think a lot of stuff's lying around, if they're just thrown out, the informal sector will pick them up. They will take the aluminium off. They will remove the cable. They don't really have the technology to process that cable properly, so they will burn it. So what we're saying is that from our perspective, there are certain things that we don't want the informal sector doing. Dealing with lead-acid batteries, for example, burning PVC. And then at the end of it, once the value has been removed, they're just going to dispose of that panel. And as Andrew has pointed out, lead and cadmium, if they're just chucking them in the river or they're putting them in a landfill or an informal dump site, that is going to leach out into the water supply. So it's about providing the alternative to that. And we, as EnviroServe, as the formal sector, think that most of the panels will, in the long term, still probably come from the informal sector, and the aluminium will have been removed. You know, what we're hoping to do is provide an alternative to the burning, and we're working with one of the CBOs in Nairobi to try and prove that that's possible. But certainly the actual panel part, we need to provide a solution. But you also then have to transport those back. The guys who's taken the aluminium and the cable off, he's not going to pay for moving it. So this is why nationally we have to have processes and costings and so on to say, how do we deal with all of these things that fall through the loop? Informal sector is great, at extracting value. But as soon as something becomes negative value, that's where we have to put in place the backstop to support them. So that's what this project is largely about as well.
Yeah. Okay, so we just heard back that Romano can't solve the technical problems. Sorry for that, but we are in a flow, so we are just continuing our conversation. And a point that has been raised throughout is the point about costs. So I want to ask both of you, can you give us a little bit of an overview of the costs of recycling that you are currently incurring, maybe in that way, Sean, since you have to ship to Dubai, just to give us an overview maybe about that. And then, of course, anything, Peter, that you want to add or adapt depending on the context from your experience.
Yeah, so from our point of view, first thing is obviously just the general business overheads. Because we're a formal industry, all the tax regulations, NEMA, all of these other things, providing proper sort of facilities and protective clothing and everything for our employees, all of that is quite a big cost. And then following a formal process that assures our customers of what we've done with the materials and allows us to give them proper disposal certificates, again, has costs. So that is the just overhead. Then you've got to collect the panels. Now, typically, in most cases, our customers are shipping them back to repair centers in Nairobi or consolidating them in Nairobi. We do occasionally collect from places like Kisumu or Mombasa if the volumes are high enough. And again, if you can imagine, even panels weigh a huge amount. So to put enough panels in a 10-ton truck, it's not a lot of panels for the amount of transport that's involved. So transport is the first thing. Once they get to the warehouse, it's not a huge problem. We take them, we weigh them, we record everything, and then we remove the cable, we remove the control box, we remove the aluminium. The aluminium and the cable now provide us with income, so that's fine. Again, that's starting to reduce the cost. The panels, at the moment, we've been, as I say, putting them in a container and shipping them to Dubai. That's about 30 US cents a kg, so say 40 shillings a kilo, just to ship them to Dubai. And in Dubai, they then landfill them, which costs us money as well. And obviously, we're paying Dubai for other things as well. So there is quite a lot of costs involved. And then on the Dubai side, historically, they've not extracted any value. So you're only getting the aluminium and the copper out of the cable. Everything else is negative value. So this hopefully is the cost reduction, not shipping the 80%. Obviously, there's more work involved in stripping the glass, but we're hoping that's fairly efficient. And as I said, if the initial equipment is paid for, it's the operational costs. So that's not a huge addition to our costs. We use our own labor, and yes, there's electricity, which is one of the problems, but that's something we will be understanding. So we actually don't know what the reduction will be in terms of that, because we know the 30 shillings or the 30 cents will come off for the 80% of the panel, but we don't know what local costs will be added on. But we're hoping then, as I say, that by the time we're shipping those panels out, and of course now, because we've reduced it by 80%, the shipping frequency will reduce because it takes longer to fill a container. And hopefully by then, Dubai will be in a situation where they will be ready to actually start extracting value from them. If not, they will store them. And again, that won't cost us the disposal cost. So everything should be reduced, but we don't know what the final values will be. But we're hoping, that we won't have to pay a huge amount in Dubai. And again, as Peter said, if they put in a technology that is viable in terms of the amount it can extract, great. The problem that happens generally with these things is technology changes, what's put into the panels changes. If you've got really good high quality panels, there's probably a lot of silver. If you've got, and again, I'm sure you guys, as you've been developing the panels, have been trying to squeeze all the possible costs out of that. So the percentage of silver going in will have been reduced and so on over time. And so it's a double-edged sword. We get more efficient in the manufacturing, which reduces the value in the recycling. But it will be very interesting to go through the whole process and see where we get to.
Yeah, very good point. Definitely, when you look at the pellets which have been produced 10 years ago and which been produced now, the 𝗣𝗩 aspect has been going down quite significant. So the current recycling value of like the older pens is higher, but the volumes are lower. So it's a bit of juggling like those kind of economics. And yeah, speaking about economics, I mean, Sean mentioned it mostly for the Kenyan context. It's about the logistics, it's about the machine costs. It's about like how much value you can also generate within the country and resell. Just from a more global perspective, again, when I studied some of these global recycling players, they become like they're running operations where they have a throughput of, let's say, 10,000 tons per year. And that's the feed they need to make their machines, which is a high investment, viable, economically viable. And as I heard from Sean earlier, I think he mentioned it was currently 2 tons per year for his recycling plant. So there's a huge gap in between, and then this is where like technology and companies need to find a way. How do we close this gap, and what do we do in between before we reach such volumes? But yeah, just to highlight this again, like those European or North American recycling plants are running on a throughput of 10,000 tons per year to make their business economy viable. And so we are in South Africa, like still far from that. That's why we need to find different solutions. We're adapting them to our local realities here.
And I think that's absolutely crucial. You know, we've said from the beginning, I've seen too many studies, even in this whole PRO process, where McKinsey give you big spreadsheets saying this is the value. The reality is that the value is not there. What's great about Africa is that if there's any value, somebody will have taken it out. We are very good at recycling, at reusing, at repurposing, at all of these things. It's just the cleanup at the end of the stuff that's not good. I mean, one of the things we're working with at the moment is, you know, we're talking to an American company who have just developed a process. Again, it's really early stage for extracting valuable materials from circuit boards. And they reckon they can start with a plant that will fit on a desk. And so this is the whole idea, is to say, okay, how do we push the stuff if it is as efficient or nearly as efficient? It doesn't have, you know, again, a lot of the problems with the European things, if you look at batteries, they've been burning. So it's a pyro process which extracts cobalt, for example, but doesn't get anything else. We need to move on from there, so do it smaller, but extract more of the quantity and the percentages. Again, going back to Andrew's earlier point. So if you're doing things in smaller volumes, you can hopefully get more out of it. But it is more sophisticated kind of approach than some of the others. And often we are just waiting for the technology to catch up. You know, I mentioned batteries. When we first started batteries, again, 7 years ago, there was a market for lithium-ion cobalt batteries because they could extract cobalt. But phosphate, there was no commercially available process. As of like 3 years ago, there now is a process for doing it. So it is people like Opus, it is people like us, it is people working together to say, how do we find appropriate solutions that move that forward and change the game? And that's, as I say, that's hopefully what the project that we're working with Hannah will achieve a little bit of. And, you know, it's great to have partners like Opus as well in the background.
Thanks. All right. We are joined by the CEO of Esak, George Aluru. And George, I think you want to say a few or more words to the topic too.
Yeah, just first, thanks a lot, Hannah, for hosting and also for the very interesting discussions that are going on. I think it's a very timely conversation. I think as Penina has mentioned, we are experiencing also a very strong growth on the CNI side. So there's a lot of solar installations that are happening. We as the association had anticipated maybe by 2030 would be at 1 gigawatt, but it seems like we'll hit 1 gigawatt even earlier. So yes, we might have maybe like a 20-year lead time from those big volumes needing to be repurposed or recycled. But I think it's a conversation we need to start preparing for. There's not so much thought as to end of life, especially on the big power plant side, other than just your normal contractual arrangements. But it would be really nice if we can retain some of the materials that we can extract from the solar panels instead of like shipping full power plants back to China for recycling. It would be nice if we already have a domestic industry that can be able to extract the necessary minerals, and perhaps even by then we would have a way of using them and not just re-exporting. So yeah, mine is just to add that on the big power plant side, this is something that will be really essential. We also I've seen in the region that there's a mad rush for all these rare earth minerals that are used to make these panels. So again, it could also be in future a source of these minerals, instead of mining the entire African continent just looking for rare earths. We can also use it as an opportunity to recover as much as we can, more or less in the way that glass is made. So we get as much as we can from the recycled materials, and also then add a bit more of the fresh rare earths to make funnels, for instance. Yeah, I just wanted to add that. Thanks a lot for the conversation. Back to you, Hannah.
Thank you, George. Yeah, and you mentioned a very critical point, because in the end, we're talking also about strong geopolitical interests around this topic. That is one point for sure. And we're talking as well about resource efficiency, since I remember the number that currently less than 1% of the global demand for rare earths is actually met through recycling. But according to studies, it could be, I think, more than 70%. And I think that our technology is advanced enough and will also head more so in that way, that we can actually do that and reduce the pressure on mining for new resources. So this is why, on a global perspective, having this in mind is very important. And then bringing it down to the macro level, I think every company can go their way. I know Penina mentioned the word crisis in the beginning, so I don't think we're somewhere there yet, but it's definitely good for companies to think about this as some form of advantage, also getting ahead of regulation locally and regionally in these topics. So yeah, I would say reach out to Sean, reach out to Peter on this. Sean, I see that you have your email address on your background there. You are not anymore in Nairobi County, you're in Machakos County now, but still close enough, right? So that also interested companies can come your way. I think it's still a good, 45 minutes ride somewhere from Westlands, right? So it's fairly easy to reach your facility.
It's about 15 minutes because you use the expressway.
Okay.
So we're literally two kilometers past JKIA. So in terms of getting to us from Nairobi now, it's actually relatively easy. I'd like to make a couple of comments. One is the industry needs to be thinking about batteries. That's another area we work very closely with on recycling, on second life of batteries, and then our next project is destruction of those. The storage will become more and more of an issue over time, and already we're starting to see end of life of some of the bigger batteries coming out of the industry. So just in general, I think everybody needs to be thinking about what are they going to do with those things at the end of life, because through the whole producer responsibility legislation in Kenya, people will be forced to deal with them properly. So it's really important to start budgeting and building processes and policies now that kind of understand that liability is coming down the line. And making sure things can be done properly. And I think, again, that whole not exporting our resources, I think when I was talking originally, people don't realize, but I'm from Zimbabwe originally, so I'm an African, and it burns me when we're sending our resources, whether they be coffee, whether they be tobacco, all of these things in the past that have just gone off the continent. And so we have to be taking control of our own destiny. And while we may not be able to compete in terms of some of the manufacturing side of it, we can at least extract those materials and get them to the point where they're saleable in a good state. I mean, we've had African countries exporting iron ore to China, and these are the things that we can't be doing and we shouldn't be doing with the sort of the e-waste opportunity as well. So I think slowly, and we have to find the solutions that work for us, but we can do it together, and that's important.
I think those were great last words to the session. Yeah, thank you so much. Again, thank you to Esak. Sorry about the technical difficulties. I mean, yeah, how would it be without it? And yeah, thank you to Sean, thank you to Peter, thank you to George, and of course to Peniina. And thank you to everyone who has joined us here. Feel free to reach out, get in touch with us. Yes, and okay, sorry, I just received another one that I can take questions. If you send them to me, I can definitely take them. For now, I can't see any more questions.
There's one more from Andrew. I've actually just
The marketability of the materials. Oh, I thought that this one was answered already. Okay, sure. Then let's continue the session. Then, Sean, if you can answer to the quality and marketability of the materials you recover.
So again, we're quite careful about how we do things. So cable, for example, even though we could just shred and granulate, we strip the outside cable. So that means we get pure PVC. So that's the one thing. That PVC can be fully recycled without any problem. The copper itself has a very small amount of PVC in it, and the smelting process will clear that out. So we actually sell our copper for the same price as pure copper that we would get from, say, a transformer. But we've done quite a lot of work. It took us, 3 or 4 years to do that, and we strip it, we shred it in a machine that was made in Kenya that was originally for shredding plastic. We granulate it in a machine that came from Turkey. Now, the problem with that is that it is not designed for the quality of cable that we're getting. And so the output isn't great. With certain kinds of cable, we can get a good enough output. So what we then did is we worked with, in fact, the guy who built the original shredder, and we've taken something that in Kenya they use for sifting maize and beans and things like that, which the guys call a shaker. And we've done a prototype project where we've created very small screens. So the negative part of the copper that we get is that the copper itself is very tiny and is multi-strand. The positive part of that is that if you put it through a screen, the PVC, which is slightly bigger from the granulation, will stay on the top of the screen and the copper will fall through. So we found a solution that works. Now, that's a prototype machine, and it's very 𝗣𝗩 𝗣𝗆. So again, there we're working with one of the universities to do a CAD design. We want to go out and laser cut the next version of this machine so it isn't just made on the side of the road, and produce a much better version of that. So again, this is about saying what is it that we can do in Kenya, which takes the negative parts of what we've got and turns them into positives. And so we're able to get pretty pure copper by sieving it, which is something that the guys in Germany wouldn't typically do, although there are processes for that. So they have better equipment than we can afford. In terms of the glass and all of that, we'll have to see, and that's it, right? It's about trying it, taking step at a time, refining it. We don't get there in one go. The same with the projects that we've done on batteries. It's taken us a lot of time to get to a point where we're comfortable with the quality of what we produce. And now we really do know what we're doing. But it is about finding how we do things at small scale, and then how we ramp those up as we've got things to go. So yeah, marketability, so long as we can get it to a reasonable quality, and those two go together, it is marketable. And we are lucky in Kenya. In Rwanda, for example, our associated company there, we're sitting on, I think, nearly 200 tons of ABS plastic at one point, because there was nobody there doing it. In Kenya, we have many more people in the semi-formal, informal area who do really interesting things. And so there is a very close relationship between what we do and our colleagues in the informal sector to make sure that we can do things that you wouldn't do in Europe. We can do more here because there are less restrictions. People will make do with less, and our overheads are lower than other countries. So as I say, there's some negatives to where we are, but there's some really great positives. And I see us as more leaders than followers in terms of the percentages that get recycled and reused and repurposed here. We get negative press about it, but I think that's because people don't understand our country.
Peter, do you want to add anything?
Not specifically to this point. I think as we're coming to a closing session, just like as Sean also mentioned, like I think it's all about collaboration and building bridges, and that's where Opus sees themselves. So like as I started our presentation, we're like a manufacturer for photovoltaic modules, but then we always kept thinking, what happens to our panels end of life, and we don't want them just to land in a dump without being handled properly. And then that's why we're getting more active, building those bridges, collaborating. That's why we're here on this call. We're working already with Johanna and Sean. We're trying to make things happen. And yeah, whoever's listening right now, like I'm happy to get a message. Reach out on LinkedIn to me if you're interested in the space. As we're trying to bring, not just sharing knowledge here on this live forum, but also in the future through our white paper, but also directly with companies. Thanks again for having me today.
All right. Yeah. Thanks to all of you, and I hope it was interesting for everybody who listened. And I hope the conversation continues. Please reach out to on LinkedIn, on email, whatever works for you. And thank you so much, and have a good evening.
Thank you.